Here, in this part, we want to go through the process of supervised machine learning task with regression to create our model. So previously, we talked about supervised machine learning task is when you have access to the input with the corresponding output inside your data. Here we have a fiction data. This is not a real data. It's just for the purpose of learning. We can see in our training set we have the earnings with the corresponding grocery spending. So for example, if a person earns $1,000, he spends $200 on groceries, and if a person earns $6,000, he spends $700 on groceries. So in real data, you have thousands of training example in your training set. You might have more than one features. So let's denote our training example as x superscript I and y superscript I. This is just a training example, and the I is the index on our training set. So for example, if we have x on index 2 and y superscript index 2, x on index 2 we have 2000, and y on index 2 we have 300. Here we have the input with the corresponding output. So we can perform supervised machine learning tasks because we have the input with the corresponding output. So here we plot our data, and the goal here, we want to do regression. Basically, with regression, we want to predict a continuous value that is close to the output value. For example, if a person earns $2,500, we want to predict the grocery spending as a continuous value that is close to our actual value. But right now, we've got nothing to rely on to predict the actual value. If we guess, we predict wrongly. In machine learning, when you want to perform supervised machine learning tasks on your training set, basically you need to select machine learning algorithm. The machine learning algorithm is going to do two tasks for you. First, the machine learning algorithm is going to map the input with the corresponding output. This task trying to find out the relationship between your input and the output. This is done through what you call the hypothesis function. We can call it h of x superscript I. This is our hypothesis. The second task here is what you call the optimization task. Why the optimization task? Because we have a set of all possible hypotheses in our training set. We want to find the hypothesis that best fit our data. There are different type of hypothesis functions. As you can see here, maybe a complex hypothesis function like polynomial or quadratic function. If we look closely our data, you can see that our independent variable and our dependent variable have linear relationship. With this linear relationship, we can then perform what you call, we can perform linear regression in our data. So with linear regression, that means we want to find the hypothesis that is linear, like this one, a straight line. Basically, there are many hypotheses, we just want to pick the one fit best our data. So this hypothesis, so we can denote it as a function of h of x superscript I. As a straight line, this can be mathematically expressed as mx plus b. And mx plus b, the m here is the slope. For example, if we say this is our hypothesis, if we select this, That's mean the slope here is the distance on y-axis divided by the distance on x-axis, and the b here is the intercept on y-axis. In machine learning, this expression here is commonly used as theta 0 plus theta 1 x. This is the intercept, which is here, and this is the slope, which is here. We can denote our hypothesis h superscript h x superscript I. By convention, we can call this y hat superscript I. This is our predicted value and is close to what you call y superscript I, which is our actual value. So basically this function depends on two parameters, theta 0 and theta 1. I can show you different. Here we have the hypothesis, and you can see that we have different parameters. Different parameters have different hypotheses. As you can see here, with theta 0 equal 3 and theta 1 equal 0, we have a straight line that is parallel to the x-axis. With theta 0 equal 0 and theta 1 equal 1,5, we have a straight line that starts from the origin. Theta 0 equal 1, theta 1 equal 1, we have a straight line that starts from y-intercept equal 1 here. So parameters can bring different hypotheses. So let's go back to our function. As you can see here, we have what you call our predicted value with our actual value. On our hypothesis, distance between the predicted value and the actual value, we want to compute all this distance. This distance is what you call error. So basically, in linear regression, one of the most widely used error function is what you call root mean square error, or mean square error. And this is the root mean square error, or mean square error is what you call the cost function or objective function. The root mean square can be expressed mathematically as the square root of the average of the sum of I to m, the number of training example of the predicted value, which is y hat superscript I, minus the actual value y superscript I raised to the power of 2. This is our cost function, and the goal here, we can call this cost function as j of theta 0 and theta 1. The goal here, we want to minimize this function. In other words, we want this function here, minimizing this function on theta 0 and theta 1, we want this quantity here to be small. So basically, as you can see, here we go back to this problem we talked about it earlier. So this is the optimization problem. In short, that's how you can use supervised machine learning tasks with linear regression to create your model. This is how things work. So you don't need to have all these mathematics. If you understand this, is an advantage. But today you can do machine learning without understanding all this mathematics works beyond the algorithm. You can use supervised machine learning with linear regression to create your model. So basically the hypothesis is our model, and we have what you call hypothesis set. We have a set of all possible hypotheses in our data, and we want to pick the one fit best our data. So this is just way of understanding the implementation of the algorithm, how the algorithm works. But you don't need to know all these things, but you can still do machine learning because there's library that can help you achieve all this with few lines code. So I'll see you in next tutorial.